Hello again, this is Vincent Robertini from the Telco team. In my IOLM video I gave a formal intro, so as promised in that video, that was the IOLM video, I promised an RFC 2544 video as well. So let's just jump right into it. First, let me start with the machines have been shipped. Calling it the machine, the FTB2 Pro Exfo units. They've been shipped to Shanghai, Singapore, and London. 2 machines per region, along with launch cords and an Ethernet card, a NetBlazer 8870. And someone will need to install that card. We'll start with that. I will show you quickly a picture of that. This is a Word document I'm working on. My boss Rohit doesn't love it. I may or may not publish it, but it is going to come in handy for this little on-screen video. So I just want to say that there's other tutorials and videos offered by Exfo. I'm going to put that together and send that out, and that'll show you a more formal way that the Exfo unit looks and operates, but that's going to be a more general Exfo driven standardization type of video. This is more the way Tower's using it. We're really with this test RFC 2544, we're really looking to pin down our latency numbers and make sure we're getting the right throughput or bandwidth of the circuit. You don't want to be paying for a 50 meg circuit, but you're really only receiving 40 meg. The unit will recognize that because you'll fail at 50 meg. But before I get ahead of myself, so back to the pictures here. So the unit looks, this is a side shot of the unit. This is a front shot right here. Side unit. Us techies like the techie stuff, right? So screws come out. You'll see the back plane, and there's a very small back plane in there. The cards go in. The IOLM card is already in the machine. It's in the unit. Someone will have to insert the 8870 NetBlazer card. That's the card that it performs a lot of tests, but that's the card that's going to be the focus of the RFC 2544 test. And here is just another view of the empty slot, and this is the card itself. It has an Ethernet port, 2 fiber ports. This little port here is it's so you could get it on a network, do some other things with it. But these are your test ports. This silver frame, those are the ports you want when you want to test something. Those are the ports you use. And you see the BNC port there. I do not know what that's for. Cable TV. Just a little joke. Okay. So someone will have to insert that card. I have a little note here in this document. Any type of card being inserted into the unit should have no power source at all, not even plugged in. Even though it's off, if it's plugged in, don't slide the card in. You want to slide the card in when the unit has no power source at all. It's not hot swappable at all, no power, not even a power plug. That's straight from Exfo. Okay, so RFC 2544. I'm going to go a little quicker now. You will receive a port assignment from Network. This is not a localized test as IOLM was. This is a test that it's going to involve 2 sites. It's a circuit. It's a telecom circuit. So you have an A side and a Z side. You're going to need 2 technicians, 2 machines at each site. 1 guy, 1 tech at one site, 1 tech at the other site. Obviously, you're going to have to be on the phone working with each other, in touch, making sure your parameters are the same. There's not a lot of parameters to set. There's not a whole lot of setup. Sometimes There's things like the MAC addresses do not resolve, things like that. But you got to be on the phone working these things out together. And I'll take you through it now. So again, you get a port assignment from network. You go to the data center, you set the machine up, and securely, properly, and you trace out that cable. So once you find your cable, your connection, your port, unlike IOLM, where you just unplugged and cleaned the fiber and then used the fiber and left the GBIC or the optic in the switch, you're going to want to take the optic out as well. So unplug the fibers, clean them, and use the optic that is in the switch and insert that into the machine. So I had a picture there where you've seen a cable plugged in. So for this instance, this is just a lab, but you would take the cable that's into the switch or the router and the optic and plug it in and insert it into the unit. Back to the unit now. You've seen this in the other video. It boots to Windows. You get to this menu once you open your toolbox. And here's the 8870 card that you just installed. Again, this port, the 720C card had IOLM and OTDR and 2 ports respectively. This has 3 icons, but that doesn't mean we have 3 ports. There's a lot of different things you can do with this card. I'm just looking at it now. I see here maybe this optical RF might be for the BNC. We're not going to go into that today. So the Power Blazer is where you're going to find the RFC 2544 test. I booted right into the menus, probably because this machine has been used a lot. You're going to want to, it should boot to the test application, and you could choose what you want here. But you see up top here, once you open your toolbox and choose NetBlazer, you see test application, test configurator, timer, and system. You see that the RFC 2544 is highlighted orange. That's what you want. So if you're in this test configurator tab, you want to make sure in the upper left hand corner there's this little diagram here, RFC 2544. If you're not sure, you can always go back to test application and make sure that that's highlighted. So you see here that I've already plugged in. I am going to unplug. I want some red up here. So there you go. There's 3 menus here and a little icon of a port. So how did we get here? This top menu here has a modify structure drop down, and I've chosen 10 gig LAN. That's what you're going to want to do. You're not going to want to set up a WAN or get into anything fancy. If you want to, I'm going to show you here quickly. You could change it. You could run the RFC. If the circuit is provided by telco with copper handoff, you can also still run this test. I just chose the copper port, as you've seen. Takes a while. And you see the little icon changed to let you know that you're on that copper port. So let's go back to modify structure. I have yet to check a copper port. Okay, before I go ahead on this, you see I pulled down 10 gig LAN again. Port 1, there's two ports that accept SFPs. I'm just going to stick with port 1. I don't get fancy. Okay, so we're back to that port that looks like it will take an LC connector type. And we're going to go through the menu. First menu, it has an interface showing you what's going on there, a network setup. It's not really setting up a whole network. You can do some other things here, but really it's just to get the IP address in here. You can set up some VLANs if you want to do another test. If you choose to test through a VLAN, the machine has 3 type of VLANs you can choose from. We're not going to do that. We're just going to set an IP. I've been using, me and the team over here in America have just been using 10.10.10.1 and 2 with a /16 mask. So this machine is set to .2. And this SFP tab down here, nothing to set here. It's telling you what I have, or at this, what I have in the unit, the optic. It's an SFP, 10 gig LR, Arista. So back to this interface. You see it's down. So if it's down like this, you want to be on the phone with the other side, your other technician. Hey, did you plug in? Maybe you got to flip pairs, things like that. The machine can act as a power meter as well if you don't have a side power meter. But if you plug in, see I just came green, you more than likely will receive power from the telco handoff. But if the other side is down, this up here might be fault detected, but you might be drawing power from the telco's handoff. However, in this case, I'm up. This is a short 600-foot spool. I'm up, and I got a nice -3 reading, so I am up. Again, nothing complicated here, just set an IP. That was the first tab. This is just MAC IP and UDP. We're not going to start setting up IP packets and UDP packets and all that jazz. We're just going to focus on one tab here, the IP tab. Again, our machine is .2. You want to set the other side to .1. Again, you'll be on the phone with your counterpart at the other site. You can discuss how you could use 1.1.1.1. You could use any IP schemes you want as long as you guys are on the same page. And I use .1 and .2 here with a /16. Both sides should be able to ping the other side just like that. I'll do that again. There's a quick ping button right here. And it's good. You see right here the MAC resolution. This MAC is resolved. Sometimes you might have to make sure that is X'd or the box is marked. You don't want to really play with your MAC addresses. You can, but this is just preset in the machine. It sees the other side. This machine sees the other machine or the other unit, and it pulled its MAC address, the destination MAC. That's what you want to happen in the real world. If that doesn't happen, there is a system reset we can take you through at the end of the video. But this looks good. This is how you should look. So there's really not much more in this tab. This last tab or menu is the actual setting up of the test. So what I'm going to do here now is I'm going to set the test up using the defaults, just so you can see what it looks like. So I did restore defaults. Little menu came. You sure? Yes. So this would be the true RFC 2544 test. I believe if Telco does this test for you and gives you the report, this is what they would do. They would give you a percentage. We're not going to do that. So we're going to set this up the way Tower desires. We want to test. We're going to come down here first and choose user defined. We want to test in megabits. The flow directions transit to receive. That's all fine and good. Throughput is the speed of the circuit, the bandwidth allotted. Back to back is what shoots back, what reflects back to the laser as the test is being performed, we're not going to use that. Frame loss is what it is. Are we losing frames, right? If you lose frames, that's no good. We're not going to check for frame loss because most of these, I think every circuit we have is up in production. We're just going to start testing them now. So if they were dropping frames, the switch would be telling us. Well, we're not going to waste time with that. And most important here, latency. I've selected user defined here. We're not going to run through all 7 frame sizes. We're going to choose our own. We're going to choose 4. We're going to start at 128 instead of 64. $256. $512. And $1024. And when we kick the test off, you're going to see all 7 there, but they're not going to run. We're just going to run through 4. Okay, so here's where it gets a little fun, right? So both units can set this menu up. However, one unit is going to take over. And we're going to do, when these circuits have some mileage between them, a far distance, we're going to use dual test set. Right now, so you click that. You can at both sites click this and go through this. And I'm saying it this way because you're going to see something here. So right now we have an X. The units are not, they could ping each other, but they're not ready to do their test yet. So we're in the test menu here. The other menus like each other. This one, we're not ready just yet. So I just clicked on subset tab really quick, and you've seen some other fields. And I actually like the way this looks. Remember the way this looks, how there's only a local to remote. Okay, I'm going to go back, and notice this is 10 gig, right? I'm going to discover the remote. There's a discover remote rectangle here and a discover remote square here. They do the same thing. Let's just do this. Discover remote. Scan for it, and it found .1. We are .2. It found .1. And we're going to connect. It said it will stop a test, but I have no test running. So let's let it do its thing. And if things pop up that you're not comfortable with, you could contact me through Slack, cell phone, or email. Not a problem. And I could team view into the machine or the units and take a look and see what's happening and help you through it. So here we have the 2 arrows indicating each machine knows of the other. We've connected. This says disconnect. When we want to disconnect, that's what we'll hit. We can do a quick ping. See, that's grayed out because it doesn't need to ping anymore. It knows. Remember, this is the test menu. Back to subsets. Notice that last time you were on the machine, you could rewind this video, I only had one rectangle here. Now that the machine knows, we have a local to remote and a remote to local. Now this is a 10 gig circuit. A lot of times, however, a 10 gig handoff doesn't necessarily mean we're using or purchase the full bandwidth. We could test at 10 gig, or we could test at, let's say, 100. Let's say it's 100 meg throughput. 100 there, and 100 here. You want to set both sides. So this is LR, local to remote. RL, remote to local. We know it's a 10 gig circuit. Apologize. We know it's a 10 gig handoff. However, the documentation and maybe the tower database says this is only 100 meg throughput. Now, the throughput field is checked. Again, you could focus on this video and always rewind it, stop it, but these are the fields, how they should all be set. I don't do anything with we haven't done anything with these fields. The time duration is 1 second, trials 1, accuracy in megabits 100% accuracy, right? All of this is left. Thresholds. We're back to 10 gig over here. Let's keep the threshold at 100. Now what would happen if this fails at 100 and let's say we lower it to 50 or lower it to, let's say, 80, and it passes at 80, then we know we're getting shortchanged. We know it's not a 100 meg circuit. This unit will be able to tell us that. This is just a threshold. You don't want to check anything there. You could do it. This is the latency unit. We could do it in mics. And there you have it. So let's go back to global. We're X'd here. And remember I said, I'm going to start the test and you'll see. But remember I said that when you have some distance between the circuits, you choose dual test set. So if this is a 5 kilometer circuit or 10 kilometer circuit, you're going to want to choose that option. Let's start. I'm going to come back to that. This is only 600 feet. So I'm going to show you after it runs through these subsets what happens here. As the test is being performed, you see 128, 256, 512, 1024. Now these were the standard 7. It was 6. This 128 was 64, and we went up respectively from there. However, we set these for ourselves, user defined. Remember, this 1024 isn't going to run. It's sort of grayed out. There's no dashes here. So it likes the throughput at 100 meg at frame size 128. This test does take a little while, and I apologize, this video will also take a little while, but again, you can stop it, rewind it, fast forward it. And when you get the units, you could always change the thresholds, set it higher and lower, and see what happens on your own. You could always run tests with this on your own. There's really no break in it. We could always do a system restore, get it right back to normal. Okay, now we're here at the other tab. If you notice, these two middle tabs are grayed out, back to back, and frame loss, we didn't check for that. So this is something interesting. It just says less than 15 mics. Okay, why is that? That's sort of boring. It's a boring result, right? So back to the setup. All that's running, just looking at your setup won't stop the test. Again, we have dual test set. I'm getting back to this as promised. Dual test set is X'd. With dual test set, you need some distance between the circuits. Otherwise, it's asking if I want to save the report. No, the results will be there. I'm just not saving the report at this time. So going back to the results, all frame sizes were just less than 15 mics. You want to see some real numbers. This machine can check down to or as low as 5 nanoseconds. So we're going to go back to the setup. We're going to do something different. only because this is such a short spool, 600 feet. So maybe Tower has an intercampus circuit somewhere. That did happen here with us on the East Coast in America with one circuit. It was between Equinix sites. It was very short. We couldn't use dual test set. We had to use loopback option. So I'm going to uncheck that. And for sake of time, I'm just going to run through one frame size. I'll keep it at 128. We're going to do discover remotes. We're going to scan again. It should still know the remote. Just because dual test set is not checked, that does not mean it's not going to discover the remote. It sees the dot 1, and we're not going to connect to it this time. We're going to loop it up. We're looping up that other machine. I'm going to stop there and jump back because I mentioned that you're going to have 2 technicians at one site. With all of this testing, you're going to want to decide who's going to be the guy running the machine. One guy will go through the setup and then not really have to do this discover connect. One tech will see this. Once you decide who's going to be the local or the head end, he will be going through this menu that I'm going through, and the other technician at the other site will see a locked screen. Okay, so hit the loop up. This is looped down because we are looped up. I'm going to close that again. We're going to start our test. Again, the loopback option of machines are for a shorter, perhaps intercampus type of circuit or connection. And again, I didn't check any other frame size but 128 for sake of time. It likes the 100. Says okay, we're getting 100, which is what we selected in the thresholds. And now we're into the latency. We're going to get a different result than that neg or less than 15 mics. We're getting 4.89 mics. That's round trip. And that's with the loopback option. Again, if you're using a shorter circuit, you want to just use the loopback option. Now you might think, can we just use a physical loopback? You can. But when you have the units, you might as well use them and let them do their thing properly. So again, I spared us running through all these frame sizes. And there you have it. So that's really all we do here for RFC 2544. A little bit more entailed than the IOLM, but that's what we do. So I'm going to go back to the setup. And I mentioned something about system restore. This isn't something you really want to get into, and if you're not sure and not confident on doing it, again, you could always call me or set time up with me and I could help you through this. If your Macs aren't resolving, you can do a system restore the fault. If you do this, you got to wait for not the unit, but the software, the NetBlazer card to reboot. Then you would have to go through every menu again. You would have to go through all 3 menus. If you do a system restore defaults. Sometimes necessary, we like to try to avoid that. Again, I hope this is helpful. Again, you could always reach me on Slack or email, set up a time to go over it remotely, and I'll be more than happy to assist. That's Vincent Robertini, VROBERTINI tower-research.com. You can also get me on Slack, and I'll email you guys my cell phone as well. I'm also going to email some documentation. I don't know if I mentioned this already. Straight from Expo, I do believe I did. And you can see more other tutorials that Expo has provided. But again, this is the way Tower wants to set this up. I hope this is helpful. Thank you.